Hello, namaste. Welcome back to the course on Geographic Information System. As I said in the previous class, we would be looking at the entire module of Geographic Positioning System. So, in the previous class, we have learned about how the Geographic Positioning System has evolved over a period of time. We also looked at different segments. When I say segments, these are the different parts of a GPS system. So, we looked at the master segment or the space segment, where you have the space satellite vehicles which actually send in the signals to the control segment. Now, the control segment corrects those signals for various errors. So, this corrected values is sent back to the satellite vehicles, which actually communicates it onto the ground. So, then the ground that receives the radio signals is in the form of the corrected radio signals, which is the user segment. So, this is where your applications happen. So, this is the entire flow of different segments of GPS, or it is the different parts of a GPS system. We also looked at how are you located on the Earth's surface. Now, once you have understood that how the GPS locates your GPS receiver on the Earth's surface, now let us also understand that what types of frequency of signals that are there, what are different systems, positioning systems that are there. As I previously said, there is selectivity also induced in this GPS system by the US Department of Defense. And the next thing that we would also look at, how, for example, how does that Google Maps can understand where you have to really go. For example, if you are looking at a restaurants from your place, it gives you where the restaurants are located, and it actually gives you the navigation route. How does this particular Google, with assistance of AGPS, can tell you that exact route from one point to the other than if it doesn't have a database, then how does it actually now help you in navigations. So, let us look at this aspects in this particular slide, particular class. So, when we look at this particular class, we would look at, as I said, satellite signals. Very importantly, the availability of GPS signals across the globe, where we would also look at waypoints. Waypoint, what do you mean by a waypoint? Waypoint is extremely important for people who are actually navigating using a GPS receiver. Also, a waypoint is an extremely important aspect when you are validating your data set that does not have any ground truth that is being collected by using a GPS system. Then you have satellite geometry. This already I have spoken, but I would really not get into this, but this is what are different concepts that I would be speaking in this particular class. So, when we look at satellite signals, so normally any of those space vehicles which are in space can transmit 2 microwave carrier signals, that is in L1 frequency, which is 1575.42 megahertz. This is the frequency of that L1. It carries the navigation message and the SPS code signals. Next, you have a L2 frequency, which is 1227.60 megahertz. This is used to measure the ionospheric delay by the PPS equipped receivers. PPS is the precise positioning service, SPS is the selective positioning service. So, these are the two different services that we have, but very important component that you can see here is the ionospheric delay. Whenever there is a issue with the GPS signals, it is because of the ionospheric loss that is there, that is either accounted or unaccounted by the GPS receivers. So, when you are looking at this, the first thing that application that you can see is surveying, the carrier phase tracking. So, when you look at it, a line of sight along the ground is not necessarily a precise positioning. Okay. If you have any line of sight across your entire surface, then it may not be your precise positioning. Positions can be measured up to 30 kilometers from the reference point without intermediate points. Please keep this in mind. If you anywhere on the Earth's surface without having an intermediate point, I can look at the reference point. With the measurement of the reference point, I can look at other points to be measured, but you should know the reference point. That is very important. Okay. To know the reference point, again you need the GPS system, which is with precise value on the ground. then carrier phase is tracked on both receivers, and changes in the tracked phase are recorded over time in both the receivers, which means when I say receivers, it is on your, maybe on your car, on your mobile phone, etc. Okay. So the concept of there is a concept of selective availability. So when I say selective availability, you can understand selective, it is selective to certain segments of users only. Or when you look at the Department of Defense, the satellite time, the message, the position accuracy was withheld for certain GPS users of certain countries. It is mainly the policy of Department of Defense, so that the countries which doesn't have the same talk as that of the US will not have the access to your precise positioning system, whereas it will have a selective availability. When you look at this, it is basically in May 2000, the Pentagon, which is the head of Department of Defense, or the headquarters of Department of Defense USA, reduced SA to few meters error. Now the when you look at SA, it is somewhere around 50 to 100 meters of error that you may get in terms of the selective availability. So SA could be reactivated anytime by the Pentagon. It can be increased. Now it has been decreased to about 50 meters to 100 meters. And when you look at this particular image here, okay, so if we consider this as the entire system that is being tracked, okay, let us say this is the entire system, okay, this is the entire region. So now when you have this particular radio signal that is coming here, if and let us say that SA is on, okay, or selective availability is on, you as a user, if your user is somewhere here, his point can be somewhere located in this location or in this location, okay. So depending on if the signal is here, so it may be located in this particular region. When you look at this is the entire signal for when the SA is on. So you are located somewhere there, which means it is about 50 to 100 meters away from the point you are located. But let us say that your selective availability is off, so it gives you an location which is as close as 5 meters to 10 meters. So this is where you may be located, okay. So if you have something like VOS accuracy, I'll explain what it means. It is even less than 3 meters of your positioning service, which means it can easily locate where you are at any point on the Earth's surface. So that is why VOS is basically used for aircraft navigation and ship navigation, extremely useful in that terms. So and when you look at selective availability, it is some of the very well known enemies of United States of America. I would not say of enemies, it was friends come foes, have selective availability, whereas some of very good nations which have good relations have precise positioning system, okay. So when we look at the GPS positioning system, we have two types, one is the precise and the one is the standard. And standard, when we look, standard is for most of the countries which actually is on a list of positioning system where the accuracy is very limited. And when you look at standard positioning system, most of the civil users worldwide use SPS without charge or restrictions. So most of the civilian application is on a standard positioning service. So normally the accuracy of a standard positioning service is 100 meters horizontal accuracy, which means the accuracy of your horizontally where your distance is located may be somewhere around 100 meters, okay, and 156 meter is a vertical accuracy. So you can see it is quite imprecise in terms of accuracy measurements, and 340 nanoseconds time accuracy. This you would have seen many times when you are actually locating a point on the Earth surface. Many of the users would have got this particular issue when you are actually navigating. and the other positioning service is called a precise positioning service. Then authorized users with cryptographic equipment and keys and specially equipped receivers. Okay, that is extremely important. Authorized users with cryptographic graphic equipment. So these are specific equipments which is manufactured for receiving GPS signals, and keys that is provided by the Department of Defense for specific purposes only, and specially equipped receivers. Only then you will be able to have a precise positioning service, which is not on your mobile phones, not on your normal GPS devices that you get for 10,000, 6,000, 8,000 rupees, not on all those mobile phones, not on all those GPS receivers. So it has about 22-meter horizontal accuracy, 27.7 meter vertical accuracy, which is quite better compared to your standard positioning service, and most importantly 200 nanosecond time accuracy, which is very important in terms of measurements on the Earth's surface, or you are looking at the positioning service. So these two positioning services are normally available, but standard positioning service that is available for everyone, but precise positioning service is available only for select people with select the instruments or equipments that are used to receive these particular signals. And when you look at the carrier phase tracking using a non-precise or the standard positioning service, if you look at it, let's say you have a car that is moving, you are moving in a car, you are moving from a point A to the point B. Okay, now the satellite orbital path is something like this. Let me draw it to you. This is the satellite orbital path which is going like this. This is the satellite 1, this is the satellite 2, let us say. Similarly, you may have another 2 satellites. Now reference receiver receives this particular position of, let us say this is a satellite, it is now giving the position of this particular receiver. Okay, now this will be the difference in x, y and z. Okay, now when you want the carrier, which is the remote receiver, if you want to understand the carrier cycle measurements, you will understand it with the difference in this particular distance that is given by your orbital time. When you look at this particular signal is then sent back to the satellites. Okay, corrected signal, this is communicated to the receiver which is in the remote position, and this receiver is the difference at this particular point of time. This is the distance that is calculated. So I did say that how you derive the distance, okay, using speed and time, okay, the time of it reaching that particular point. So looking at this, the carrier phase positioning is normally done. That is how you can position yourself on the ground. Then you have waypoints. I said this is extremely important in terms of how you track your route. For example, when you are looking at this, if you are traveling from, this is your let us say point A and you are going to point B. Okay, so now if you see a satellite has to know this path, the first thing is this path is in your database. If you are looking at the GIS, so this entire database is fed. This database has selected has a huge number of points. Okay, so with this also you have these points are connected through a line segment. So it says if it is a line segment, it is a road. Okay, so now what GPS basically does is with these points it tries to map your location to this end point. Okay, so that is through these points are called as waypoints. Okay, this is how your way, if your point is somewhere here, your GPS has to move something like this. Okay, so you have number of points that is connected here, so your GPS tracks this through the waypoints. So a waypoint is basically is based on the coordinates entered into a GPS receiver. So what I am speaking here is in terms of what coordinates we feed into the GPS in order to move to a particular point. Okay, it can be either a saved position fixed or an user entered coordinates. So it can be created by any remote point on the Earth's surface. It must have a receiver designated code or number or a user supplied name. So with this, what happens is that the entire waypoint, that is whatever you has located, it will when you reach that particular location, it beeps and tells you that you have reached that particular location. So once you have entered and saved it, a waypoint remains unchanged in the receiver's memory until it is edited or deleted. Okay. So the once we have understood the waypoints, let us understand very interesting point of it. For example, how you reach a particular restaurant from your house. Okay. So let us look at it. Let us say you are going to some maybe let us say a lakeside restaurant, okay, and your home is somewhere here. So this is your home and you are going to a restaurant here. Now where with the database that is built in the GPS system sorry GIS system, GPS knows that this is your point, this is the path that is taken to reach this point. It also knows that this is another path that may be taken in order to reach this. It also knows that there is one more path through which this particular thing can be reached. So now you have three different paths. The first thing it calculates is the distance between each path. Okay. So once it has looked at distance between each path, it will determine what is the shortest distance. Okay. So the shortest distance is given through this. Let me take a different color. So shortest distance is, sorry, the shortest distance is through this. Okay. So now this is my shortest distance. Now it starts looking at these points that are connecting to form the line segments, otherwise called as a waypoints. With this waypoints, it makes at least at every 10 kilometer to 30 kilometer range, depending on how big is your route. Okay. It starts looking at a main waypoint. Okay. So where normally a turn is there, it can be even 5 kilometer many a times. So you can see these are the points where there is actually a curve. So it locates all of these main waypoints, okay, or points of known location where exactly GPS has to tell the user that there is a turn or any of those aspects. In a small city road, which may be something like this, you have every point here is a star. Okay, these are the main waypoints. So including this. So when you look at this entire region, then you have main way. With this, it starts navigating to the route as you drive and reaches this point. That is how a GPS plans your navigation route. Fine. So if you have understood this, the next point, thing that you that may be extreme, that is very interesting, is how GPS receiver sees the route. Okay, it is not as simple as the previous one, but when you look at the GPS receiver, as I said, these are the main waypoints. Okay, but due to your positioning service that you have, GPS receiver can look at all of these green stars can be the positions that a GPS receiver may take you. That is why you can see when you are actually navigating in this route, it would sometimes the receiver would be something like this next to the road, or it may be saying that there is an error of 10 meters, 20 meters, 1 kilometer. Okay, that is the adjustment error that you have to make in your entire the way you are navigating. It looks at all of these points. Okay, now with this, it is actually locating where you want, where exactly you have to go. So that is the error that is induced by your system, either through the positioning service or through the ionospheric delay. So with that, the movement of your navigation of your vehicle starts, and when it is reaching at every point here, the distance is actually calculated at every location, and now you can find out approximate delay in these particular distances. That is what it gives, 10 meter delay it may be that your navigation is 10 seconds delay or 15 seconds delay, so that you know that instead of reaching that particular location at 45 seconds, you will reach at 40 seconds. Okay. Similarly, it goes on until it reaches the last point, where it is actually the end point of your entire travel route. Okay. So when you look at this, if you have a very precise positioning system where you have an error of 3 meter or less, then it means to say that it is instead of having these many circles, you may be somewhere here itself. Okay. If let us say you have a this is what for a standard positioning service, but if you are looking at a precise positioning service, this particular thing may hardly have any effect in terms of reaching that point. Okay. So when you look at your satellite geometry, basically it also matters a lot, because just by a bad geometry, your entire signals, the strength of your signal may get worsened. So when people say about ideal satellite geometry, these satellites should be placed in such a way that normally you have something called as an inner circle at a certain distance from the equator, and there is an outer circle. So when at least some satellites in the inner circle and many satellites in the outer circle is extremely necessary, and most of the satellite signals should not crisscross each other. That is another very important point when you are looking at the ideal satellite geometry. So if you look at this particular system, okay, if this is the thing that is ideal, but when you look at many of your systems, most of your systems are something like this. It has a very poor satellite geometry, where if you look at the entire signal, there will be many satellites that is in the inner circle, and the outer circle will have many more satellites, and most of if you look at the entire geometry that has been these satellites have, so these have a crisscrossing signals, which means that it is actually inducing error by itself, and also the measurement error, the distance error creep in at every point on the Earth's surface. So if you have something like this, then it shows a poor satellite geometry. Okay. So when we are looking at this, there is also a concept of how your relative positioning between the user and GPS satellites are also affected. For example, if you have something like this, there is no crisscrossing, so you have a best signal that comes, and your measurements is quite precise based on the positioning service you have. But if you have something like this, even with a precise positioning service, you may have certain errors induced because of the satellite signals. So Department of Defense has taken care of these issues, and at least 99.99% of the chance these issues are always no, I mean it doesn't occur in most of the phenomena, but there are chances that certain places it really occurs, and the error is too high. To give an example of signal error, so this is what it means. So you have a satellite signal that is reaching, and this is a satellite, and they are crisscrossing each other, because of which the error is actually induced into the system. Okay. So you have a poor satellite geometry even in terms of something like this, whether it is joining at a particular position or it is having. So now what happens when it is actually measuring a point, the two satellites measure this particular location, right? So now with the way the previous two signals were indicating, it would have given the location somewhere in this region. Now it is giving a location somewhere here. So that is how your locational information, the distortion increases in terms of positioning service. So that is one, in case you have a poor satellite geometry, this is what may actually happen, for your analysis. Okay. Especially that is not good for when you are trying to look at your the way you have some validation data that you are connecting, and how your validation data is there. So to summarize this entire presentation, we looked at GPS satellite signals. So when we looked at GPS satellite signals, I did say we have two types of frequency, the microwave frequency, that is L1 frequency, other one is the L2 frequency. Now, I would suggest that in case you have some interest in understanding the L1 and L2 frequency, I would request you to go back, look at its electronics. It's actually fascinating in terms of understanding the electronics, and most importantly, the bigger research that is happening today is in terms of the GPS is in terms of this particular signal receiving. So please look at the satellite signals, how they are received, and if in case you have enough time. Otherwise, why I have specifically introduced this GPS system here is people should understand how a GPS system works. So if someone gives you a GPS tomorrow to do a validation, so if you understand some basics point, this particular thing doesn't cover the entire aspects of the GPS, but it is selectively giving you some important information about the GPS system. So if you are able to understand this, it may be useful when you are trying to go into the field with a GPS system. You can exploit the very good or thing of the GPS system and get better results. So then we looked at carrier phase positioning, which is extremely useful in terms of positioning yourself on the ground. And the next point that we looked at is selective availability. So I did say that selective availability gives you a huge error up to 100 meters. So when if the selective availability is not there, the error can go up to 15 meters, and if you have a WAS system, then it is 3 meters. So this selective availability is given to only certain countries which are not in good terms with the United States of America or Department of Defense of United States of America, and the selective availability is actually degrading the entire system of how the measurement is done. Okay, so though the 100-meter error that was introduced has been reduced to almost closer to 50 to 100, in the range of 50 to 100, but though you have 50-meter error that is induced today also in certain regions. So that makes every application erroneous. Okay, so that is what we learned. Then we looked at the positioning services, that is the precise positioning service and your standard positioning services. When we look at precise positioning service, we have a good accuracy measurement in terms of horizontal and vertical accuracy measurement. Precise positioning service can only be received by certain specialized equipments and specialized designated receivers only, and whereas standard positioning service is for all civilian applications. So we also looked at various applications that we can have. Then we looked at what is a waypoint, how does waypoint matter, how does a satellite actually easily locates you, or a GPS receiver locates you through a waypoint, number of waypoints. Then we looked at how a waypoint is marked when you have different positioning system, the waypoints can be either side. So how do you actually with this waypoints, what are the errors that are induced, and normally you would have seen such errors in your maybe when you are actually navigating. And then we looked at what is the ideal geometry of a satellite. We looked at how the satellites has to be located, and what are the different ways that particular satellite receives its signals or its signal is sent. Okay, if there is a crisscrossing signal, then the error is induced. If the error is induced, then your distance measurement is actually provides it with an error. So with this we learned that what is the best kind of geometry that we may have, or an ideal geometry that we have with the satellites, which are taken care of normally by the Department of Defense. With this we would end this particular class. So I hope everyone has understood the basics of the GPS part. Then now let's in the next class we would look at more precise positioning systems which include the DGPS, and also looking at the WAS system, how these are extremely helpful in either for navigation or for example the WAS system is used for aircraft and naval systems. So how those particular applications are very different in terms of how the receiver receives or perceives the signals. So let's look at all of these. Okay, as of now I hope I have tried to convey how the GPS works. So this is how normally a GPS system works. When you have an handheld receiver, you receive only a radio signal. So with this, let me end this particular class. Thank you. Let's meet in the next class with more details on more important issues. Thank you.